In this video we're going to demonstrate how to calculate 3 by 3 determinants by calculating this determinant of the matrix 3, 1, 4, minus 2, 5, minus 3, minus 6, 10 and 7. Okay, and these vertical lines either side of it means the determinant. And the way we calculate this is we go across any of the rows or the columns. So I'm going to go across the top one, but you could go down here, you could come down here. Okay, you could go across the bottom there. And what you do is, when say you choose this element here, you ignore the row and column it's in, so you ignore this column and that row, and then you calculate the 2 by 2 determinant of this little matrix here, and we call this the minor matrix of 3, alright, of that top element, top left element. And then so you do 3 times that determinant, and then you would say, I'm coming across here, I would subtract 1 times, and cross out that, this and this, create a 2 by 2 matrix. You find the determinant of that, and then so you subtract 1 multiplied by that, and then you would do plus 4 multiplied by the determinant of this 2 by 2 matrix here. You might say, well, how do I know whether I should be adding or subtracting? We have something called a cofactor matrix, not a cofactor matrix, sorry. But anyway, it's just a sign matrix of the signs you should be using. So plus, minus, plus, plus, minus, plus, minus, plus. So you just start with plus, then you just keep changing the sign. And what this matrix allows you to see is when you should be changing the sign of your. So for example, if we went down this column here, we would keep the sign as it is, 3, then we'd have minus minus 2, so that would be multiplied by 2, then we'd have plus minus 6, so we have minus 6. Okay, so I'm now going to go through the calculation. This determinant is equal to 3 multiplied by the determinant of 5 minus 3, 10, 7, minus 1 multiplied by the determinant of minus 2, minus 3, minus 6, 7, and then we got plus 4, the determinant of minus 2, 5, minus 6, 10. Okay, this determinant here is equal to 5 times 7, 35, minus 3 times 10, so that turns out to be 35 plus 30, so that's 75. So we've got 3 times 75, then we got minus, just ignore the 1, minus 2 multiplied by minus 7, so that is minus 14. And then we got minus 6 times minus 3 is 18. We want to subtract that, so we got minus 14 minus 18, which is minus 32. Minus 32 gives us plus 32. And then we want to add 4 times minus 2 multiplied by 10 is minus 20. And then we want to subtract minus 6 times 5, so that's minus 30, that's plus 30. So we've got minus 20 plus 30, that's 10. So we get 3 times 75 plus 32 plus 40 gives us 297. Okay, so hopefully you can see the general method for calculating determinant of 3 by 3 matrices, and this will be useful in the next video when we look at inverses of 3 by 3 matrices. For now, I'm going to introduce the simple method for finding the inverse of a 2 by 2 matrix, and then we will generalize this to any square matrices and give an example of 3 by 3 in the next video. So if we've got a matrix A, B, C, D, we'll call that A as well. Then A inverse is equal to 1 over the determinant of A multiplied by D minus B minus C A. So we just swap over these first two and change the signs of the first diagonal, the leading diagonal, sorry, is what I meant to say. And then we swap the signs of the other diagonal we have here, and we divide all by the determinant. So you can clearly see by this definition that the determinant, if the determinant is 0, we can't define this inverse. So that does lead us onto a fact. 0 determinant implies no inverse, and then we call such matrices singular. So if your question asks you for what values of whatever for a component in the matrix, it might give you a matrix with some numbers in it, so say 1, 4, minus 3, and then D, and the question might be for what value of D is the matrix C singular for. Okay, so you'd have to get your determinant formula and solve equal to 0. So now let's just do an example. Say I've got the matrix M equal to 3, minus 1, 5, 4. M inverse is equal to 1 over the determinant, so 1 over 3 times 4 is 12. And we do a minus 1 times 5, so that's plus 5. Now we're going to swap 3 and 4 over, so we get 4, 3, 1, and minus 5. Okay, and that's equal to 1 over 17, 4, 1, minus 5, 3. That's all we're going to do in this video. Like I said, we're going to go on to inverses of 3 by 3 matrices in the next one. So hopefully you'll check back in to see that video. If you did enjoy this video, please be sure to like and subscribe, and as always, let me know any questions down in the comments.